Hello everyone. In this third video about machine learning in model evaluation, we will learn about classification in model evaluation. Let's begin. The metrics for classification are based on counting how many predicted classes equals to the observer ones. The simpler way to evaluate a classifier is when the classes are well balanced in dataset, training and test. Accuracy is the metric for this scenario. The predicted classes are matched against to the observed ones, and the number of matched ones is divided by the size of the dataset. We can see we can see in this example uh, that each value, real value, is compared as a comparison with predicted values, and this return a true or false value, considering that false is 0 and true is 1. In most of the cases, the classes in a dataset are skewed, that is, the number of classes is not balanced. For instance, in a dataset with examples of benign and malignant tumors, maybe most of the examples are labeled as benign tumors. If 96% of the tumors are labeled as benign, and the model outputs benign for every example, its accuracy will be 96%, a very good accuracy. However, we know that the model is not able to predict malignant tumors. Several metrics have been proposed, and we discuss three of them: precision, recall, and F1 score. First, we present some definitions to help present the metrics above. True positive means the classifier matches the positive classes. False positive means that the classifier matches negative classes as positive. True negative means the classifier matches the negative classes. False negative means the classifier matches positive classes as a negative. In this picture, we can see a confusion matrix that represent real values that machine will try predict, and in vertical we have predicted values, values that machine predict, and we have true positive, false negative, and true negative, or for us understand better this confusion matrix, let's understand in terms of pregnancy analogy. In this picture you can see how this is real values and this is predicted values. In first picture we have a woman pregnant, and the doctor says that woman is pregnant, is positive and true. The machine predicted this is true, and real is true. In the right side, in the right picture, we have an example of false positive. The man is impossible to a man is pregnant, but the machine predicted that his is pregnant, and here we have an error. In this picture, you can see a false negative. the the woman is pregnant, real, it's one, and the machine predicted that she is not pregnant, is error number 2, type 2 error. And finally, in this image, we have an example of true negative. The man in this picture is not pregnant, and the machine predicted that he's not pregnant, is correctly. Well, precision recall and F1 score can be defined as follows. Precision is true positive divided by true positive plus false positive. Recall is true positive divided by true positive plus false negative. And F1 score, that is 2 multiplied by precision multiplied by recall divided by precision plus recall. Precision, for what we use this precision, recall, and F1 score. Well, precision, when we want exactness, that is, your classifier is covering the positive classes confidently. Recall, completeness, how many positive examples your classifier has missed. And F1 score gives the harmonic mean of precision and recall. Remember that accuracy can be also calculated as follows: true positive plus true negative divided by true positive plus false positive plus true negative plus false negative. That is